Okay, class, we need to talk about EKG waveforms, okay? So first things first here, you have in an ST elevation MI, we're going to look at actually two different things here, okay? So just hang tight for a second in the window here. So look at ST elevation MI at the top here. What happens is that, okay, here's, a P wave, QRS, and then you have ST segment and then a T wave, okay? Two different things. You have to first, you're not here to read 12 leads right now, but if you're saying when you're looking at a box, okay, how do they really tell whether there's an ST segment? So this is what, okay, MI, ST elevation MI looks like, okay, large Q wave. That means, you've actually infarcted all the way through the wall, and now what happens is that it represents a Q wave on the EKG waveform. The ST elevation, simply what is it telling you of the ventricles are trying to recover during the QRS and during the QT. So when you actually have a problem with perfusion, it's going to show up in the EKG waveform as a ST elevation MI when somebody's ruling in for an MI. So let me show you something else. They go by something called the J point. I'm not going to test you on this, but you should understand what you're looking for, because a couple of things. There's an imaginary, what we call an isoelectric line. And they say that somewhere around 2 boxes over, and you don't have to measure that, but you look at this ST elevation. Look at from this line on up. It's at least a couple boxes. That's how you know there's an elevation. Likewise, here's another picture for you. When you see ST depression, they talk about this J point reference, because you have to look at when it is about to completely relax, okay, what is happening as far as myocardial damage that's actually causing an ST elevation to show up on an EKG or an ST depression. So again, imagine, so where the PR is, that's where you look at your isoelectric line. So just imagine here, just go across from PR to QRST, right? And look at, this is at least 5 boxes. This is the J point. Look at the ST segment here. It's at least 5 boxes above. So you shouldn't have any ST elevation. It should be close to this imaginary, what we call the baseline, right? And it's, if it's 1 centimeter over, okay, that's one thing, but it should be relatively close to this. You got to have at least 2 boxes or higher. You're not going to have to measure. You can kind of eyeball this. Clearly, this is 5 little boxes on an EKG. You have an ST segment that is not near the isoelectric line. So in other words, it's caused enough damage here that it didn't relax itself, and that's why it shows up like that, because the body is trying to perfuse, it is trying to contract and relax, but because now you have some dead part of the muscle with a release of cardiac enzyme, it shows up on the EKG waveform as actually damage. So this is telling me somebody is ruling in for a heart attack right here. Now versus here. Okay, let's look at the opposite. Here is the imaginary line. Likewise, for this patient who's having ST depression, right, here's kind of where the end of the QRS is. They call it this point of reference of where you look at the beginning of the S to the end of the T, right, where this little ST segment, you're going from contraction to relaxation. So look at, there's actually here, if you flip it the other way, you actually have a depression. So it's a negative, it is a negative deflection, okay, versus a positive deflection for somebody having a heart attack. When you see ST depression like that, so there's a couple of boxes, that usually represents ischemia, okay? So you've got, wait, here, MI versus ischemia. So you have time to actually reverse the ST depression, versus here somebody's already ruling in for a heart attack. They would have to reperfuse the area, either through thrombolytics, they take them to the angiogram, they open up the vessel, etc. And so understand though that with ischemia, especially when you see inverted T waves like that, these are permanent changes that are set in, like the Q waves they will still show up after like a permanent MI that's actually gone all the way through the wall. Now you do have to know something. You do have to know there's also something called non, so if you add an N to that, this is ST elevation. If you add an N to it, that's non-ST elevation MI, which means somebody had an MI and you didn't see any of this. You had no EKG changes. How do you know they had an MI? They had positive cardiac enzymes. Okay, that concludes this portion of ST elevation and ST depression.